Hey everyone, welcome back to my channel. Today, I'm excited to share a story that will help you understand linear regression, one of the simplest yet most powerful concepts in machine learning. So, picture this. You're sitting at your favorite coffee shop, the one with the perfect vibe and the smell of fresh coffee in the air. You feel it, right? As you sip your latte, your friend who happens to be the cafe owner comes over looking puzzled. Says to you, hey, I've noticed that more customers show up when it's warmer outside, but I can't seem to figure out the pattern. Can you help me predict how many people will come in based on the temperature? You think for a moment and smile because you know this is a job for linear regression, the superhero of predictive modeling. Well, maybe not. All right, let's break down what linear regression is. Imagine you have a bunch of data points, like the temperature on the different days that customers come into that restaurant and the number of customers in each of those days. Linear regression is all about finding a straight line that best fits this data, helping us understand the trend and make predictions. In mathematical terms, the line is represented as y equals mx plus c. Let me break this down for you. Y is what we are predicting, in our case, which is the number of customers. Then m is the slope of the line. It tells us how much y changes when x changes. X is our input variable, which happens to be the temperature in this case. And c is the y-intercept, which is where the line crosses the y-axis when x is 0. In simpler terms, think of it like a recipe. You adjust the ingredient of a meal and linear regression helps you predict the outcome. But before we dive into the code, let's talk about visualizing the concept. Picture a scatter plot of temperature on the x-axis and the number of customers on the y-axis. Each dot represents a day's data. Our goal is to draw a line through these dots that captures the overall trend. This line minimizes the distance between itself and each dot, and that is what we call the best fit line. So now let's get into the code. As we bring this concept to life in Python, we'll create simple data sets and see linear regression in action. To do that, we are going to follow these 8 steps to build our linear regression model, and we're going to go through them one by one. The first thing is to import the libraries. And to import the libraries, we're going to be using NumPy, and here you can import NumPy as NP. The second thing is pandas. Another one is matplotlib, which we are going to be using to make our plots. And we are going to be using sklearn model selection, which from the model selection, we are going to be using the train test split to split our data into training and testing set. Then we're going to be using sklearn.linear model to import linear regression that we're going to be using to fit our line in this case. So we run it and import our model. After doing that, we come to the step 2, which is to create sample data set. And here we're going to be using a dictionary to create a sample data set where the first key in the dictionary is temperature and the other one is customers, and we have the values attached to them. The next thing is to turn this dictionary into data frame using pandas. Then we run this to see the outcome. The next thing then will be to visualize our data. It is always good to see how our data looks like before we even go ahead to build our model. Then we use matplotlib to visualize our data. I will make a plot of the temperature against the customers. And let's see that. So as we made a plot, you can see that we now have our points on the chart. And this is telling us something that looks like there's a linear relationship between temperature and the number of customers. So let's move on to now build our linear regression model. Then the next thing to do will be to select our input and our output, our X and our Y. In this case, our X is temperature, which is a feature or what we call the input, and our Y equals to the customers. And that is what we are selecting here. Now that we have both, the next thing will be to now split them into training and testing using train test split. And here the test size is 0.2, which means 20% of the data set. Let's run it and see. Now that we have that, we now need to move on to our model training. To train our model, we're going to follow this step. The first thing will be to get a linear regression model and store it into this parameter called model so that we can use it to fit our data. Then you call model.fit after initializing linear regression here. Linear regression is coming from the sklearn model that we imported, and we imported linear regression. Now we are fitting it. We just say model.fit, then we pass in our X train, which is the X train that we splitted here, and the Y train. And we run it to see a model. That's it. Quickly, we now have a linear regression model. It is that easy. So the next thing is to make predictions. And to make predictions, we're going to have our prediction in this way. So we create a variable called predictions, and we're going to pass our model to .predict into it so that we can store our prediction into this variable. While building the model, we use the fit option here while building a model. And here now, we are going to be using the predict instead of the fit. So we're going to be predicting on our X text. So the next thing is to make comparison. To make comparison, we need to compare our actual data, which is the Y test that we kept during the splitting process of our data using the train test split. And we're going to have the predicted values. Then we're going to compare the two. So what we have before and what we are predicting. And we're going to print a comparison. So now we can see the actual here and the predicted here. And from here, you can easily see what is happening with our predictions. Here, it is kind of 4 times lower, and here it is about 3 times higher. But we can't just use what we think or just looking at 2 data points. We need to have a way to visualize the regression line. And that's what we are doing in the step 7. To plot a regression line, we're going to have our X passing into the plot. Then we have our model prediction. Here, we could have passed in prediction just like we have stored it initially. But here, we are just using model.predict to make the prediction directly while making the plot. And we're going to see what is happening. And here is our prediction line. So you can see that our line goes through the data point seemingly accurately. So we can say we have our best fit line. But this is also not enough to totally see what is happening. We need to evaluate our model. And to evaluate our model, we're going to be using 2 options. We have 2 options to evaluate our model. One of them is the R-squared value, and the other one is the mean squared error. And we're going to be using both in this case. So from sklearn.metrics, we import mean squared error and R-squared. For R-squared value, when the value is close to 1, it can be said to be a good model. And the next thing is we now have our MSE here, mean squared error, and we call on a mean squared error function. We pass in our Y test and the predictions we made. Then we do the same thing for R-squared, where we get our R2 score, which is what we imported here, and we pass in our Y test and the predictions that we make. The next thing is to print it out so that we can see them, and we run a code. So these are mean squared error 8.47, and for R-squared it's 0.99, which seems that the model is good. But our interest most time when we build our model is to reduce this mean squared error as much as possible and to increase the R-squared as much as possible. So that is it. You now have a good linear model, or should I say good? Well, something that is useful to just show you how linear regression works. That's it. We just use linear regression to help our cafe owner make sense of how temperature affects customer turnout. Remember, linear regression is just the start of your machine learning journey. There are many more complex models out there, but mastering the basics is the key. So linear regression is the basics. So if you enjoyed this tutorial, just like the video, subscribe to this channel, and let me know in the comments how you'd use linear regression in your own project. Thanks for watching, and see you in the next one.